Identify the type of reaction and species involved. The reaction represents the titration of acetylsalicylic acid, C9H8O, 4, which is a weak monoprotic acid, with sodium hydroxide, and AOH, a strong base. The chemical equation is C9H8O. 4 plus OH to the power negative gives C9H7O4 to the power negative plus H2O. Understand the behavior of a weak acid-strong base titration. When a strong base is added to a weak acid, the neutralization reaction goes essentially to completion because the hydroxide ions, OH to the power negative, have a very high affinity for protons and will strip them from the weak acid molecules. Apply the definition of the equivalence point. The equivalence point of a titration is reached when the number of moles of titrant added, OH to the power negative, is stoichiometrically equal to the initial number of moles of analyte, C9H8O, 4 in the flask. Here, exactly 2.00 times 10 to the power minus 4 moles of NaOH has been added to neutralize the 2.00 times 10 to the power minus 4 moles of C9H8O. 4. Determine the dominant species at the equivalence point. Because the neutralization reaction goes virtually to completion, almost all of the starting weak acid, C9H8O, 4, has reacted with OH to the power negative and has been converted into its conjugate base, the acetyl salicylate ion, C9H7O4 to the power negative. Compare the final concentrations. At the equivalence point, the flask contains a solution of the conjugate base salt. Only an infinitesimally small fraction of the conjugate base will hydrolyze water to reform the weak acid. Thus, the concentration of the conjugate base, C9H7O4 to the power negative, is vastly greater than the concentration of the remaining unionized weak acid, C9H8O, 4. This mathematically means that C9H8O, 4, is less than C9H7O4 to the power negative, which corresponds to option B. The correct answer is option B. C9H8O4 is less than C9H7O4 minus.